Hello, students. Let us think of a battery. Tell me everything you know about batteries. Okay, I drew a battery right here. Okay, good. You have a positive and negative end. And you also know that batteries, when you attach to a wire, you can light a light bulb in the path. And you have to make sure it's connected to both ends. So a battery gives energy, gives electricity. So if it gives electricity, electrons, that means electrons are flowing from one end to the other. And you also know that the circuit has to be complete. So where do you think those electrons are coming from? There has to be something in the battery that's giving away electrons, right? On this end. And there has to be something in the battery that's taking the electrons. Okay, so it must be a redox reaction where one is giving away the electron as it becomes oxidized and the other side takes the electrons as it becomes reduced. Okay, so today we are going to be learning what happens inside a battery. Okay, so let's go ahead and look at this example. What I have here is a beaker. The beaker has some water in it and the water looks like it's blue. The reason it's blue is because it has some copper +2 ions inside the beaker, okay? So what I did is we put a piece of metal, and this metal is zinc with a 0 charge. Over time, there's something going on the outside of this zinc, and remember it's a solid in the beginning, and over here it's still solid. But it looks like the zinc is dissolving somehow. And it used to be blue, but now it's not as blue. So you might think, I wonder what's happening. Think about it. What do you think is that solid on the outside of the zinc? Okay, so the first thing you should think is that copper is being used up. It used to be copper +2. And it's turning into something else because it's not as blue. This is the blue aqueous solution, AQ. Okay, so that means copper must be turning into this black substance here. It looks like it's black, but it should be like a copper color, like an orange color. What's happening is the copper is taking in some electrons, specifically 2 electrons, and it's turning into copper solid, and that's what you see here. Okay, so you can tell the zinc is dissolving, right? Where do you think those 2 electrons are coming from? Okay, so it must be coming from the zinc. The zinc, which has a 0 charge, is giving away 2 electrons, and it becomes zinc +2 as it becomes dissolved. You can't really see it, but it's in there somewhere as ions. So what happens here is the zinc is giving away electrons to the copper like this. Okay, so if we put this in the same beaker, we can't harness that energy. You already can tell that this is spontaneous. It happened on its own. And I showed you a video, an example video of that, with the silver ions as well. But it does the same exact thing, but instead of silver, it's just zinc. So it took in the electrons. Right now, we can't really harness that energy. What if we put them in 2 different containers? Okay, and that's what this looks like up here. So what they did is they put the zinc on one side, one beaker, and the copper on the other side. And by doing that, we can put a wire between them and have the electrons go through, and it will conduct electricity. So let's go ahead and draw one right here. So take a beaker, make it 2 of them, okay? I'm gonna go ahead and use a different stroke here so I can fit it. So we have here, in this beaker, you're going to put some copper +2 ions. Now we can put zinc on this side. The zinc is a solid, okay? we're going to put zinc, and the zinc is going to give away electrons. So we're going to put a wire on the outside here, attach it to the zinc, right? And the copper plus 2, let's make it blue because they're blue in the beginning. The copper plus 2 will take in the electrons. So copper plus 2 will take in the 2 electrons, and it's going to turn into copper solid. Okay, here the zinc used to be 0 charge, and it's going to give away 2 electrons, and it's going to make zinc plus 2 floating around in here, and you're going to see this kind of dissolving, like disappearing. Okay, so we can harness that energy here. We can put a light bulb because electrons are going this way. We can put a light bulb there. This is like a battery, right? Okay, or a source of energy. Over here, we can put, the wire is not going to go straight into the water because, I mean, you're just going to get electrocuted, right? You need a piece of metal to conduct that electricity. Now, that metal can be anything. The metal can take in the electrons and make it flow into there, okay? Another thing is you need some kind of a bridge, like a salt bridge, and to make this circuit, like to close the circuit. Okay, what we have made here is we've made a battery. A battery will give you energy, and the energy is coming from moving electrons. Okay, so that's the practical aspects of it. Another word for a battery is a voltaic cell. The reason they call it voltaic is because Alessandro Volta, his name is Volta, last name is Volta, he came up with it. Okay, so a voltaic cell must be spontaneous, obviously. It has to be oxidation reduction. One has to give away the electrons, one has to take it, a redox reaction for short, and it's a transfer of electrons. We can use that energy to do work, and if we put a wire across it, we can measure that potential. This is called the voltage. This gives you a 1.10 voltage. Okay, if we make the electrons flow through an external device, of course it has to be in separate beakers. We call the setup a voltaic cell or a battery. Okay, so in this lesson we will be learning about chemical change. It's chemical because we have molecules or atoms inside that inside the cell, and we're turning that chemical into electrical work, into electricity. Okay, some terminology here. What is electrochemistry? It's using chemicals to make electricity. Okay, electrochemical cells, the reason they call them cells is because there are beakers. Those are called the cells. You need redox, and it will make electricity. Now we have 2 types of electrochemical cell. The first type is called a voltaic cell. Sometimes they call this galvanic cell. What we've been talking about is this is called a voltaic cell or a galvanic cell, and it makes electricity. The reason they call those galvanic or voltaic is because of 2 scientists, Luigi Galvani and Alessandro Volta, constructed early versions of this battery or cell. Okay, that's one type. The second type is called an electrolytic cell. We will talk about that way towards the end of this chapter. The difference is that the first cell, galvanic or voltaic, make electricity, while the second one will need electricity. You're forcing a redox reaction to happen that is not spontaneous. Okay, while this is spontaneous, because electrons just want to move, this is not spontaneous. Therefore, you have to force it. Okay, so this is a voltaic cell. Can you tell me what's another name for voltaic cell? You're right, galvanic cell. Tell me, does this give energy or take? Or does it give electricity or take electricity? It will give electricity, okay? And on the next video, I'll show you an example of a voltaic cell.